Hi everyone and welcome to Activity 23. Today we are going to talk about the sum and difference identities. So in our previous lessons we talked about finding angles that are the exact values on our unit circle, but unfortunately can't always find all of the exact values beyond what we already know. We can, however, use certain identities to help us find exact values of some other values, and we do that using the sum and difference identities. So for sine, if you're adding up two angle measures, so for instance, x plus y, we would do sine of x times cosine of y. And then depending on if you're adding or subtracting will depend on the order of this. So if you're adding, you would have the addition in between there. If you were subtracting, this would be subtraction. And then we would have cosine of x times the sine of y. Cosine's formula is going to be cosine of x times cosine of y. And this one you have to be careful because if you are adding, it's actually going to be subtraction inside here. And if you're subtracting these two values, it's actually going to be addition. And then sine of angle x times sine of angle y. And then for the tangent, it's going to be tangent of x plus, if you're adding, tangent of y, all divided by 1 minus, if you're adding the originals, tangent of x times tangent of y. If you're subtracting, this is subtraction, this is addition down here. So basically what our goal is to find two angles from the unit circle that we do know that either add or subtract to be the value at hand. So for instance, if I'm looking at 15 degrees, I can use 60 from the unit circle minus 45, and I would get that value of 15. And I know the sine and cosine of 60 and the sine cosine of 45. Same idea with 75. I could do sine of 30 plus 45, or cosine 30, cosine 45, tangent. We know those values from the unit circle. Okay, what you can't do is something like 30 minus 15 because we don't know 15, right? You want to use values from the unit circle. So there are more than one option for these. For instance, we said for 75, 30 plus 45, we could have also said 120 minus 45. That also would have worked, right? Or instead of just saying 15 degrees being 60 minus 45, maybe we used 45 minus 30. Those, again, are both values from the unit circle that we know. 105, for instance, could be 150 minus 45 to get that. Now, when it comes to radian values, you can, of course, find two radian values that add to be this. Like, for instance, if we had over 12, we could do, if we think about pi over 6 as 2 pi over 12 plus 3 pi over 12, these both reduce to be values from our unit circle that we, in fact, know. Okay, but quite honestly, it's a lot more time consuming to do that. So what I like to do instead is just convert this to degrees first. So multiply by 180 over pi, pi's cancel, 5 over 12 times 180. This is the same thing as saying 75 degrees. So we could just work this in degrees and then use some of the values above to get that, right? You would get the exact same answer. Or pi over 12, okay, sure, we could, find two radian values that work, or we could just convert this to degrees and say 112 times 180 is 15 degrees, and we can use what we already did up above to work that. Okay. Now, how are we actually going to find these exact values? Okay, so this is where we're going up above, and we're going to say, okay, some values from our unit circle that become 75. For instance, 30 plus 45, I would say, okay, sine of 30 degrees plus 45 would be the sine of 75. Now, again, when we write this in our calculator or in our actual formula, we're using this up above because sine of 30 plus sine of 45 isn't just going to give us the sine of 75. Too easy, right? So we would have sine of x times the cosine of y. And then since this is a plus sign, we'd have a plus sign because they match in this one, blue and blue. Cosine of x times the sine of y. So basically what's happening is 30 is our x value, 45 is our y value. So sine of 30, cosine of 45, cosine 30, sine of 45. And from our unit circle, we know that the sine of 30 degrees is 1/2. Cosine of 45 is square root of 2 over 2. Cosine of 30 is square root of 3 over 2. Sine of 45 is square root of 2 over 2. We know that the 1 times the square root of 2 is square root of 2. 2 times 2 is 4. Square root of 3 times square root of 2 is square root of 6. 2 times 2 is 4. And then finally, we could just write this as one fraction with that common denominator. Square root of 2 plus square root of 6 all over 4. For cosine, okay, again, similar idea. We're going to start by picking two values from the unit circle, and this can vary. I'm going to choose this time 60 minus 45. And again, if we look at our cosine up above, we're using this formula. Okay, be careful. We have cosine of x cosine times cosine of y, and then be careful if this is a minus sign, it's the opposite for cosine. We would have then sine of x times sine of y. And again, this time the x and the y are going to be 60 and 45. So we're going to plug this in. And then from our unit circle, we are going to just fill in the value. So cosine of 60 degrees is 1/2. Cosine of 45 degrees, is square root of 2 over 2. Sine of 60 is square root of 3 over 2. Sine of 45 is square root of 2 over 2. And then similar to before, we end up with square root of 2 over 4, square root of 6 over 4, which can just be rewritten as square root of 2 plus square root of 6, all divided by 4. Now, you can always double check these, right? If I take the cosine of 15 degrees, I want to double check that my exact answer is going to be the same decimal approximation. So square root of 6 plus square root of 4, and then divide that by 4, our common denominator. Square root of, should be square root of 6 plus square root of 2. That's why. And then divide that by 4. You should get the 0.96. And they matched. Okay, so we know that we did this correctly because these are the same value. So you can always double check that. All right, now on the next page, we are going to talk about some tangents. All right, with our tangents, we are adding and subtracting these values. To get 105, I would take tangent of 60 plus 45. And remember with tangent, it's tan of x. In this case, if we're adding, that's going to be addition. And then opposite sign down here times each other. So tangent of 60 is going to be our y value divided by our x value. So in this case, that would be square root of 3 over 2 divided by 1/2. We know that the tangent of 60 is going to be equal to square root of 3. And then 45 would be the square root of 2 over 2 divided by square root of 2 over 2. That's just 1. So essentially, that's what we're plugging into here. Tangent of 60 degrees for the x value is going to be square root of 3. And then down below, or next here, we have tangent of 45, our y value, which is 1 for both of these. So the top, we end up with square root of 3 plus 1, and then on the bottom, 1 minus square root of 3 times 1, which would just stay square root of 3 since anything times 1 is itself. Now, what makes this a little bit tricky is that this is not how we are allowed to leave our answer. We must keep this as simplified as possible. So what we're going to do is we're going to multiply by the conjugate of the denominator. So our denominator was 1 minus square root of 3. We're going to multiply top and bottom by the conjugate. And we've talked a lot about in this that our conjugates, you can kind of shortcut. First times first, last times last. 1 times 1 is 1. Negative square root of 3 times positive square root of 3 is negative 3. Up top, though, we have to work a little bit harder. We end up having to double distribute. So square root of 3 times 1 plus square root of 3 times square root of 3 is just 3. 1 times 1 is 1. 1 times the square root of 3 is the square root of 3. So again, we can combine some like terms. On the top, we end up with 3 plus 1, which is 4. Square root of 3 plus square root of 3 is 2 square root 3's. And then on the bottom, 1 minus 3 is negative 2. Last but not least, all of these are divisible by 2. 4 divided by negative 2 is negative 2. Negative 2 divided by negative 2 is negative 1 square root 3. Or we could just write the negative square root 3. Now again, we are able to double check these. Okay, so we can take tangent of 103 and double check. Did we get the same answer as when we approximated here? Or they get the exact answer? The answer is yes. So we can kind of double check that fact. Now again, I recommend instead of using the radian measure on this, we look at the degree measure. And in this case, if we convert, tangent of 75 is the same exact thing as tangent of 5 pi over 12. But it's a little bit easier to see that 75 would be 30 plus 45 or something else if you choose it that way. So again, we would be taking the tangent of our x value, and then in this case plus, since we're adding tangent of our y value, 1 minus then tangent of 30 times tangent of 45. Now the tangent of 30 is the, again, y value divided by the x value, 1/2, divided by square root of 3 over 2. After we rationalize, becomes square root of 3 over 3. Tangent of 45 is just 1. So when we plug this in, we end up with root 3 over 3 plus 1. And then square root of 3 over 3 times 1 would just be square root of 3 over 3. Now this time we have a fraction within a fraction, all this kind of craziness. So what we're going to do to start before we multiply by a conjugate is let's multiply everything by a 3. Because what happens is the 3 in the denominator cancels with the numerator, so we can just be left with square root of 3 plus 3. And then again, multiply it through that fraction. This part will cancel because we distributed. And now we at least have everything in terms of whole numbers and not fractions. All right, similar to the last problem, we are going to multiply by the conjugate of the denominator. So in this case, we are going to multiply by 3 plus square root 3. Again, we're just flipping that sign. Conjugates, when we distribute them out, you could just do first times first, last times last. And then you, up top, need to double distribute those. So square root of 3 times 3 plus square root of 3 times square root of 3. And then 3 times 3 and 3 times root 3. Now again, what you're going to notice is that we can combine like terms. 3 plus 3 is 12. 3 square root 3 plus 3 square root 3. We have 6 square root 3's. 9 minus 3 is 6. And last but not least, everything is going to simplify here. 6 divided by 12, 12 divided by 6 is 2. 6 divided by 6 is 1, square root 3. So you're going to notice a pattern here that these often simplify to be very similar, just kind of depending on if it's a positive or a negative. All right, last part of today is officially we can use these to verify as well. So for instance, I know that the 50 could be broken into 30 plus 20, and then we can see if we plug these in for x and y, that the sine of 30 times cosine of 20, sine of x times cosine y, plus cosine of x, which is 30, times sine of y, which is 20, we can verify that that was true, right, using our formula. Oftentimes you're going to see this, though, again, to simplify and make this our goal using values from the unit circle already provided. So again, if we have a sine problem, we would want sine of x times cosine of y, which in this case is x. And then notice this is a minus sign, so for sine, we would keep it the same. Cosine of x times the sine of y, which, in this case is x. Well, sine of 90 degrees is 1. And then cosine of 90 degrees is 0. Anything times 0 cancels out. And then 1 times cosine ends up equaling cosine, which was our goal from the beginning. So we could check off that we verified that. This time, I'm going to make this left-hand side my goal. And I basically have two different ones I'm plugging in, right? So for the first part, we would have sine of x times cosine of y plus cosine of x times sine of y. So that's coming from this part. But we're also adding on to that this other piece, right? This time it would be sine of x cosine y minus cosine x times sine of y. And what we're going to notice is this negative cosine x times sine y and this positive cosine x times sine y, we are adding a positive and a negative, so they essentially cancel out. Sine cosine plus sine cosine equals 2 sine x cosine y, which is our goal. So just some practice with some verification on that. All right, we will definitely be working more with all of these in class. Thanks for watching.